So we'll go live in 8 minutes.
Is it the very hot season in India right now? No?
Mani is drinking. I suppose it's...
I suppose it's very hot season in India.
Okay, I have 5 minutes to prepare a coffee. 2 minutes.
Yes.
Okay.
You have time.
Thanks.
Just one coffee, Jean-Pierre, not red wine.
Whatever is fine with you.
Oh, you know, this is the reputation of French people.
Yeah.
In the past, I was working with a Japanese woman, and she said, is it really, do you used to drink red wine at breakfast every day? So it was very strange when I heard that. So, no, not in France, for lunch or dinner, but not at breakfast.
Devansh?
Yes, sir.
Can you please brief about the flow of events once again?
Sure, sir. So we'll start in 5 minutes. I'll begin with the introduction of this event, our panelists. Then I would request Professor Asim Mishra and Dr. Pradyuman Yadav to just give a short intro and their opinion about this event. Then I would request Dominique to start his presentation.
Okay, then?
After Dominique, sir, he has two presentations, one on technology, one on applications. After that, Jean-Pierre would be talking about Interchim and the solutions. After that, we would have Arjun, and after that, the Q&A session.
Yeah, I think the word of thanks can be proposed by Basant.
All right, sir.
Basant, it is okay?
Yeah, perfectly fine.
Yeah. And when are you going to do the poll questions?
The first poll is after I finish the introduction.
Okay. Devansh, please switch on your video. We'll take one picture.
Yes, sir, I'll do that.
Okay.
I think from the picture, SRM Dr. Misra is missing.
Just 1 minute. Yeah. Dr. Mishra,
One
please.
more,
Little, we
JPP.
want to take one picture.
GPP is my control screening.
Okay.
Okay. Dr. Pradhaman, you attended our ELSD webinar also yesterday,
No, sir, I didn't attend actually.
but I saw your this one in that. Probably.
No, yesterday I couldn't make sir that.
Okay.
We'll go live in a minute.
You are also doing the YouTube.
Yes, yes, sir.
Streaming? Okay. Because the Singaporean people wanted to see in YouTube because they are not allowed to log in any PCs and attend webinar, but they can go through
Okay.
YouTube.
YouTube.
Oh.
And many who can be connected on YouTube? I mean, everybody, or you have a
No, no, no,
password?
no.
Only the
Devansh is
people who have the
doing
link.
a live YouTube streaming. Some of the customers from Syngene and Biocon group, since they could not attend the webinar in the PCs inside the lab, they wanted us to share in YouTube.
Okay.
Because if it is available in YouTube, they can see it anytime.
Okay, got it.
Okay, I'm going live. Yes, the panelists are joining now. Yes, sir. A very good afternoon to all the attendees. We welcome you to today's session on making purification easier, intuitive, productive with flash chromatography. I am Devansh, your host for the day. So once again, a very good afternoon to all the panelists and attendees. We are pleased to bring a highly interesting sharing the learning online session to you on making purification easier, intuitive, and productive with flash chromatography. Based in the heartland of France, Interchim has over 100 staff members supporting a vast range of reagents and associated consumables beyond its manufactured brands. It also manufactures the world-renowned PuriFlash technology. Interchim is a family-owned company established in 1970 by Jean Bock, PhD, a former research director from Sanofi Aventis. From standalone modules to lab-scale flash, Interchim offers the most comprehensive purification product line. All PuriFlash instruments use HPLC pumps, which are virtually maintenance-free and provide many years of continuous service. Spinco Biotech is the leading channel partner in India with our mission of bringing the best of technology and enabling science in India. With 33 offices and 700 plus Spincoites comprising of service, sales, application, and admin support, we have a well-established network to support the scientific community in India. We are honored and proud to partner with Interchim for their PuriFlash range of products. Today, we are honored to have with us the distinguished panelists. I would now like to introduce all the panelists. We have with us Professor Aseem Mishra. Professor Aseem Mishra, after completing his PhD in biochemistry from Jawaharlal Nehru University, Delhi, has served as a visiting research fellow at National University of Singapore, a Wellcome Trust DBT-IA Early Career Fellow. He has also served as the lead for nanotechnology at Savir Biotech, a quick hire scientist at CSIR Institute of Mineral and Material Technology. He has served as a UGC assistant professor at Utkal University. He has also served as the Chief Technology Officer at the KIIT, the Kalinga Institute of Technology Business Incubator. He has served as an Associate Professor, School of Biotechnology, KIIT University, Bhubaneswar. Currently, he's serving as the Chief Executive Officer, co-founder at Prante Solutions. Prante is building key technologies for affordable molecular prognosis. We are honored to have you with us today, sir. We are also honored to have with us a distinguished panelist, Dr. Pradyuman Yadav. After his PhD in biochemistry from CCS Haryana Agricultural University, Hisar, India, he has worked as a scientist at ICR NAARM. For the last 10 years, he is working as a scientist in agricultural biochemistry at the Indian Council of Agricultural Research, the Indian Institute of Oilseeds Research, Hyderabad. He is published in international journals. He has many publications in international journals. He has won multiple awards and fellowships. In fact, he has won the Ministry of Human Resource Development Mysore Scholarship for Doctoral Studies, awarded by the CIIL Ministry of Human Resource Development, Mysore. He has presented multiple poster presentations in international and national conferences. We are also honored to have today with us Mr. Jean-Pierre Bouzère, the International Distributor Manager for Asia and Middle East, Interchim. We have with us today Mr. Dominique Dequer, Project Manager, Separative Technologies and Group Leader, Liquid Chromatography, Interchim. We have with us today Mr. S.R. Manivanan, who's serving as the Executive Vice President for Spinco Biotech and is responsible for overall non-pharma business in India. He's also heading the flash chromatography, the Interchim product line for India. We have with us today Mr. Arjun Raj, who's serving as a product manager for HPLC consumables and the Interchim flash chromatography lineup. He has previously worked as a scientific researcher in Biocon and a product manager at Bona Agela Technologies. Finally, we have with us Mr. Basant Kumar Padi, who is working as a business manager for the non-pharma unit in Spinco Biotech for the East region, that is Hyderabad, Andhra Pradesh, Telangana, and the neighboring states. I am Devansh from Spinco Biotech. I take care of marketing events in Spinco Biotech, Gujarat. We are pleased to have all the panelists with us today. I would now like to request Professor Aseem Mishra and Dr. Yadav to enlighten us with a few words as we begin today's session.
Hi, this is Aseem Mishra. So I have been a purification scientist for almost 20 years of career now. And all the while, I'm happy to say that Spinco hasn't disappointed me. Such a long relationship doesn't really last in the market these days. But happy to be a partner and getting support from Spinco all the while on various HPLC as well as flash chromatographic systems. I also thank all the panelists and the team for making this webinar happen. I'll be happy to answer any questions at the end of the session.
Thank you, sir. Dr. Yadav. Yes, sir. Dr.
Devansh, I think
Yadav.
Dr. Yadav's webcam was not working. So let him speak in non-video mode itself. Fine.
Sure, sir. Yes, Dr. Yadav, a few words from you, sir. All right, seems like he's having some technical issues. I would now like to request Mr. S.R. Manivanan to enlighten us with a few words as we commence today's session.
Yeah. Thank you very much, Devansh. On behalf of Spinco as well as all our customers, I would invite Dominic as well as Jane Perry for this wonderful session on flash chromatography. So Dominic will focus on the basics, which will certainly enlighten all of you on the technical aspects of the flash chromatography. Jean will further explain about interchip focus. In fact, this is the 5th webinar in series which we are doing it on the Sharing the Learning web series, which is done by Devansh. So I would like to really congratulate and appreciate the efforts of Devansh. In fact, yesterday, most of you have attended the webinar on ELSD. Last week, we had the webinar on dairy solutions. So this is the 5th such webinar which Devansh and Spinco are doing. So I wish all of you a great learning and a great session ahead. Thank you very much.
Thank you very much, sir. I would now like to request Dominic Duquer to start the presentation.
Dominic, you can share the screen.
Yep, absolutely. So, namaste to everybody, and thank you for attending. We will just go into overfly some fundamentals of chromatography to well understand the behavior of a chromatography column.
Excuse me, Dominic, can you please increase the volume? We are not able to.
Yeah, absolutely. I will try this. Okay. Is it better right now?
Yeah. That's better. If you can increase a little bit, that's fine.
Okay. Well, I was saying that we will try to overfly some fundamentals to understand chromatography, and we will focus on physical-chemical characteristic of the adsorbent, in fact, first.
Yes, Dominic, sorry to interrupt you. So for all the attendees, if you have any questions, kindly type them in the Q&A box so that we can take them up. Please do not type the question in the chat box. And yes, before we begin, I have a quick poll question for all of you. So I'm launching the poll right now, which will give us a better idea about how to go about with this. So we'll just take 30 seconds for this question.
Okay. I can go on?
Yeah, yes, just 10 seconds more.
Yeah.
All right, thank you. The question was, which of the following purification technologies are you currently using? And 35% of the participants are using semi-prep, 16% are using flash, and 49% are using none of the above. Thank you for your answers. I request Dominic to please commence the presentation.
Thank you, Devansh. I go on. So I was speaking about physicochemical specification of the adsorbent, and in fact, we will see how those physicochemical specification influence the compound separation, and especially by their size, their shape, their chemical grafting also, and the column capacity, which has a huge importance. And we will have an overview about the laws governing the separation, in fact. So liquid chromatography is a technique of separation. I think everybody attending to this meeting are knowing this separation, but the most important fact for the separation is the selectivity. Selectivity means that the compounds will behave differently inside the column and will flow through the column with different interaction between the solvent and the adsorbent. And finally, the compound will be separated when they go out of this column. The goal for many people in the laboratory is just to have the best purification, in fact. So the purification by liquid chromatography is involved by selectivity, but also another goal mixed to this first one is the capacity. And when you are able to reach purity and capacity, you're able to have the best productivity. That's our real target to Intershim. That's why we are manufacturing some specific tool to achieve this goal, productivity, mixing, purity, and capacity. So let's start with adsorbent. The media, we have two main media at this time for the purification in the column. These are silica gels and also polymers. Silica is still the main media used for 75% of the application. And the characteristics of this media are very important to understand how you can manage a very good separation or not. So silica has an advantage because it's a very non-expensive product, very common on the earth, and we can easily modify it by chemical grafting. The disadvantage of silicas is the pH stability. Silica gel are dissolving with high pH, so this is a problem if you want to use some product, some buffer with high pH in your solution, but it's not the problem today. The most important thing is that we can modify the silicas with a lot of different chemical bonding, and at this day, Intershim is able to provide around 50 different silica-based selectivities. For polymer, the advantage of polymer is chemical stability and also pH stability from 1 to 14. And the other main advantage of polymer is the specific surface area. When I was speaking about silicas, the common silicas exhibit around 300 or 400 square meter per gram of specific surface area. When you work with some polymers, you are able to reach more than 1,000 square meter per gram. So you can see immediately the advantage of this material. You will be able to charge to have a big capacity with polymer based than some silicas. We will mainly talk about silicas this morning, and the feature of silica is like this. You have silicon atoms linked to oxygen atoms, and on the surface you will see some hydroxyl, we name them silanols, and the best silica is able to exhibit a lot of vicinal silanols. You have also geminal one. This is a kind of twin silanols. And unfortunately, we can also see on the surface of silica gel siloxane bridges, which are not very useful for the purification. Another feature important for silica gel is the shape. On the market at this time, many people are still using irregular. Irregular are like some small pebbles. And at this time, in Teoshim company, we try to move a lot of customer on spherical. When we speaking about spherical particle, you can see it's not really totally spherical. This is not a football ball, in fact, but a kind of spheroidal material. Inside the both material, you have pores, and pores are like small funnels inside the ball, and the solvent, the compounds will go through this ball, interacting with the silanol or the chemical modification we have made before. But the main importance are the shape, because the shape will have a big impact about the behavior of the flow in the column and the dispersion also of the molecules. So now we are focusing directly on this ball, and the characteristics of this ball are the diameter first. So we can find on the market a lot of different particle size. And so when we are speaking about particle size, we are speaking about the diameter of this ball or this pebble. And you will see for analysis some very small diameter, 0.7, 2.2, 3 micron, also still 5 micrometers. For preparative, 10 micrometers, a little part of 5 micrometers, and also 15. And for flash chromatography, in the 10 past year, many people are used to work with 50 micrometers particle size, but you can find more and more 15, 30, and 50. The other feature of this ball are the pore diameter. Remember, we have seen this pore here. So in details, on the market, many manufacturers are able to provide different pore diameters, 40 up to 1000 angstrom. So imagine you have a big hole inside this particle of silica gel. But when you are increasing this pore diameter, unfortunately, you are decreasing the specific surface area. So for 40 angstrom, you can have around 700 square meter per gram of specific surface area. For the main tip, the common tip on the market, 100 angstrom, the surface area is around 300 or 400 square meter per gram. And you can find for very big molecule with 1000 angstrom pore diameter, just 10 square meter per gram. So when you are choosing silica gel inside a column, you have to take care of this parameter. This is really important to know what is the specific surface area, which involve the capacity, the charge capacity of your column, and also the size of the molecules. If you want to separate biological molecules, you have to choose a big pore diameter, and you will see the 300 angstrom is at this time the most used on the market for big protein, and 200 angstrom for peptides. All those measurements are just average values between the minimum and the maximum, because when a manufacturer is making a particle size, he can say to you, okay, this is a 5 micron, but this is a 5 micron, more or less 1 micron. And for the pore diameter, this is the same thing. When you are buying a silica gel with 100 angstrom pore diameter, this is more or less usually 15 angstrom. So 85 to 115. We can modify the silica gel, and it's more and more common now. It's very common for the analysis. You have a lot of columns, the well-known C18 grafting silica gel, but you can find also C4 for protein purification, C8, C18, phenyl, diol, amine, cyano, and ion exchange, cation and ion exchange in the anion exchange also. Or, most common for purification at this time, just a virgin silica gel with a silanol on the surface. What happens when you are modifying this silica gel? So remember, we were speaking about the pore size. We have a pore size. On this example, you have a 100 pore size. When you make a modification with a C18, this C18 molecule has a size also, and the size is around 23 angstrom. So in the funnel, you will find C18 on this side, C18 on this side, C18 on all the sides of this funnel. So finally, the real size in this pore is reducing to a space about 60 angstrom, sorry, just able to allow the molecule to go right through this funnel very easily. So it's important to know that because the silica gel has a lot of different features given by manufacturer and also for the chemical modification, leading to a different behavior of molecule and interacting with the chemical grafting. Some manufacturers are able to graft C18 inside a very small pore, but if you graft a C18 inside, for example, just 40 angstrom pore, you will just have a 20 angstrom space for the molecule inside, and it's very, very poor. Also, the purity of silica gel is very important because ultra pure silica gel are able now to have just a few amount of iron, calcium, sodium inside, also other metal, because metal are increasing naturally the acidity of the silica gel, leading to the famous tailing of peak with basic compound. When you are speaking about the grafting, many people are talking of percentage of carbon, and it's leading directly to the coverage rate in terms of micromole per square meter. And that's induce absolutely the accessibility after bonding and the behavior of your compound inside the column, a chromatography or a puriflash column. So what happened in terms of modification? You modify the silica gel. The silica gel naturally is a polar compound with silanol. So you can make some polar modification also to enhance the selectivity of your column. So if I choose to graft an amine on this is still a polar silica gel, but she shows a different behavior with your molecule flowing through the column and enhance the selectivity of pharmaceutical or chemical specific compounds. But I can choose to modify completely the behavior of the silica gel and graft on this one. I repeat, silica gel is a polar media, and I decide to graft something to make the reverse phase. We call reverse phase. You certainly know this name. And this is because we are grafting something non-polar, like C4, C8, and C18. Here you can see the increasing polarity of the adsorbent, and also here the decreasing. But it's not an absolute rule, because sometimes you can also modify the grafting of C18 to make it less polar from a C8 grafting. So take care about this. You certainly know on the market some C18 AQ able to work in 100% of water. This is due to some modification we add to the C18 on the silica gel, other modifier like cyanopropyl or aminopropyl. So here you have some picture showing the interaction with the molecule and the silica gel. On this way, you can see the interaction with a polar molecule having the same hydroxyl functionality, and here the alkyl chain having an interaction with the alkyl chain of the molecules. So it's important to choose the right column. Like if you are practicing a racket sport, for example, and you want to play tennis, I suppose you don't want to use a badminton racket or a ping pong racket. You will use a tennis racket. But also there is another thing very important when you are practicing your sport, to choose the right ball. The right ball for our example is the solvent. If you want to play badminton, you will not choose a tennis ball to play with it. It's not really possible and efficient. And see, if you have choose the right racket, what means this is the right column, you have to choose the right ball, so the right element. If you use silicate gel, a virgin silicate gel, which is a polar compound, we name this, you are working in normal phase, and you have to choose a non-polar solvent in majority, and just a few amount of polar one to allow the molecule to dissolve and go through the column. In the opposite, if you want to work with a reverse phase, that means that you have bonded with, for example, a C8 or C18 graft on the silica gel, you have to work with a more polar solvent and a less polar one, just to allow the molecule to go through the, stop the interaction with the graft and go through the column. So the first one is a very routine purification. You know, many people are working for flash chromatography with normal phase on a virgin silicate gel. But more and more, people are moving to reverse phase and working with what we name a sophisticated purification, showing an enhancing selectivity in this column. What is the magical way in a column at this time? You can see we inject a sample. A sample is a mix of different color balls or molecules, and they will go through the column and will be separated differently. So on this example, you see that the yellow team of molecule has a very poor interaction with the adsorbent and a very important interaction with the solvent. So she will go first out of the column. The blue one has more interaction with the adsorbent, so she will be the second. And what happened with the red and the green? We see a not complete separation. Because in fact, the interaction with the adsorbent of the blue team and the green team is almost the same. There is just some little difference, but you will not be able in this choice to separate the both. The result you have on your chromatogram is the peak are overlapping. And so you have a part of the first one in the second one and a part of the second one in the first one. So we can compare a peak, a chromatographic peak, to a Gaussian curve showing some separation or dispersion steps, and the name is sigma on this picture, showing that even if you have a big overlapping of the compound, you can see that just with 4 steps of dispersion, you can reach a very high purity of your compound. But it's also linked to the response of the compound with the detector you are using. For a UV detector, you have to be very careful because the response of different molecules are not the same, and the surface is not directly corresponding to the concentration of the compound inside. So here you have some example of what we call the resolution. This is the total ratio of separation of a molecule inside your column. And you will see that when you increase this name of resolution, you are increasing the separation of the peak up to almost 100% when your resolution is going to 0.5. The best way, the complete resolution is about RS equal to 2. 2 value is almost complete separation of the peaks. So we will see now how the shape of the silica gel and the capacity of the column has an importance in your purification. I will start first with this one on the right of the slide, irregular silicas. Is it very difficult to have a real particle size defined for this irregular silica gel? The answer is yes. It's very difficult to say, is it 50 micron particles or just 5 or just 30 micron? So you can see when you pack a column with irregular, you have also a lot of small particle inside. And it's very difficult to see a step of separation inside. In the opposite, when you are packing your column with spherical ball, you can see immediately that you have some step of separation inside this column, very well defined, and there are more and more if your diameter is decreasing. That means that you improve the capacity of separation of your column when you are decreasing the size of the particles inside this column. In this example, this diameter is twice of this one, and you will see that you can have more and more steps of separation with a smaller particle size. What is it, this step of separation? We call this efficiency. Efficiency is directly linked to the particle size because it's a kind of a stage of separation. Like in a building, you have some different floor. In the column, you have different floor directly linked to the particle size. But unfortunately, due to the distribution of this particle size, you will have different plate heights, so different efficiency in your column, and it's not completely proportional to the particle size. You can see that with a 50 micron, the separation step will be about 40 micron, but with a 30 micron, it's more. It's more than 3 times just the particle size. It's around 100 micrometer. So the more is the particle size, the less is the efficiency in your column. You have on this slide some example of the particle size going to from analysis, very high efficiency analysis with 240,000 plates per meter, and you will go through for the most common purified size you can find at this time for 50 micrometers. You can hope to obtain a 7 or 8,000 plates per meter, but in reality, in a flash column, that's less, really less than this theoretical value. Also, when you are using a column with small particle size, you have also another advantage. This advantage that you can use a best speed of solvent. When I am speaking about speed of solvent, I'm speaking about the flow rate. So on this slide, you will see that when you use just a 50 micron particle size, you can reach around 5,000 plates per minute, but on an optimal flow rate, very poor, just 2 or 3 milliliters per minute. If you want to work with a smaller particle size, for example, a 15 micron, the optimal efficiency of this column will be around 4 milliliters per meter, but if you increase the flow rate, you can achieve still a high efficiency even if you are at 50 milliliters per minute. And the comparison between 15 and 50 micron is very huge. With 15 micron, you obtain around 10,000 plates per minute. At the same flow rate with a 50 micron, you have just 2,000. So you will see immediately the difference and the advantage to have smaller particle size. The other disadvantage, and we don't see this in the presentation, needs more explanation, is the pressure resulting of this particle size. So we have here some example of separation between 5, 10, 15, and 30 micron on the same chemical modification. And you see immediately that the efficiency is linked directly to the peak width. And when you have a small peak width, you will be able to more separate two compounds from another, very close in the same area of your chromatogram. One very important parameter right now is the void volume. So what is the void volume in a column? The void volume of the column is composed of interstitial particles volume between the particle and the particulate pore volume. We have spoke about that before in the beginning of the presentation. When you add together the interstitial pore volume and the particulate pore volume, you obtain the void volume of the column. Flash column, analytical column, preparative column, whatever is the column. You have always a void volume inside. And you will see immediately on the chart here that with very small particle size, the void volume is really smaller than with big one. For flash chromatography, a common 50 micron micrometer particle size, the void volume can reach very easily 75% of the global volume of the column. So it's important to know that because your sample, when you inject it in the column, is completely diluted in the solvent. You have here all the fundamental laws of the separation in chromatography, explaining what is the retention time, the retention factor, the separation factor, which is selectivity, very important parameters, and also the efficiency, remember, directly linked to the particle size of your column. And finally, when you mix all these parameters, you obtain the resolution, which means you have a good separation of your compound or not. But this famous void volume has a real importance because the retention time is a kind of x time the column void volume of your compound. So if at the beginning you have a big void volume in the column, you will have a big retention time also. And also, the worst of the worst is the dilution of your compound inside this void volume. Finally, you can have a lot of solvent to evaporate just to obtain the pure compound you have separated because the void volume of your column at the beginning was very important. So the less the void volume, the less the collection volume and the retention time. This is important. And you will see on the chromatographic laws here, T0, T0 here, it's directly linked to the void volume, V0 and T0, and everything is linked to this T0 or void volume V0 on the equation. The goal, in fact, for you and many people making a purification is just to choose the right adsorbent, the right solvent, the right column packing, the right particle size, the right specific surface area to enhance the capacity in terms of charge on your column, and to obtain a good purification. A good purification is a very good separation of your compound. On the left, you have an example of flash chromatography columns showing a bad separation. But most of you are using, firstly, before a flash chromatography column, you are making a TLC. And you will see on the TLC if the separation is correct or not. In this example, the yellow one is not completely separate from the blue one. But the behavior in the flash column will be almost the same. The separation will not be achieved, and you have a mix of yellow and blue, giving a green here, a green compound. So what happened in this example? Perhaps the permeability of the stationary phase is not good. Perhaps there is some water inside the silicate gel. Perhaps you have chosen an organic modifier, and this is not the good choice. Or you have injected a too high quantity on the colon in the same time. And perhaps you have not made the right gradient on your apparatus. So the goal is really to just compare what you obtain in TLC, if you have a good separation, and to transfer it on your flash chromatography column with almost the same condition of elution with just some modification, because the silica of the TLC is not always the same than your flash chromatography column, and to transfer this just to find the best compromise to obtain a good separation with a good purity and a good capacity, which lead to a good productivity. So on our website, you can find a lot of application made in this way, and also you have some application coming from our Genius software, which is included in our apparatus, able to just move very easily from a TLC to a flash chromatography, making all the calculation to obtain this goal. So thank you very much for your attention to this presentation, and I hope this has helped you in the comprehension, understanding of the separation on flash chromatography.
Thank you, Dominique, for the wonderful presentation. So, for all your information, Dominique is one of the most experienced scientists in Interchim with over 30 years of experience. He wears multiple hats at Interchim, like setting up HPLC, prep, flash, SP, columns, packing, management of all the adsorbents. Then he was also involved in the development of Genius applications, and he is also looking after various marketing aspects, technical support, working as a project manager and group leader. So, if you have any questions, this is a great platform to have your questions and doubts solved. For the next talk, I would like to invite Mr. Jean-Pierre Bouzers. Mr. Jean-Pierre Bouzers, after his education in business management techniques, has extensive international experience in Asia, Middle East, and Europe. He has worked as an import-export sales manager, was involved in the creation of a trading company in Hong Kong, and has developed a strong network in Asia and Middle East. Currently, he is working as an international distributed manager for Asia and Middle East at Interchim. I would request Jean-Pierre to please take over.
Hello, everyone. First, I will try to introduce Interchim company, even if Devesh done it a little bit before. So it's a French company dedicated to the science with its own research and development laboratory and its production capabilities. So the CEO is Mr. Lionel Bock here, and his father who was research director at Sanofi Aventis, professor. We are in the middle of France, just in center at Montluçon, the name of the town, and we have also next to Montluçon another place which is called Saint-Victor. We have different places, in fact, but I think the best way is to show you a quick movie, if I can open it. Okay. Okay, so you can see here the different building, and you see Mr. Lionel Bock, and you are in the central pole where the secretaries take care of all the order with the packing list, perform invoice and shipment and everything. Then you can find a different meeting room, and we have also a lot of departments. Here is IT department. This is Didier Charbonneau, who take care of all the department, and we are following Lionel Bock, the CEO. Next door is, in fact, the chromatography desk with SP, sulfate phase extraction, HPLC department, and prep department. And here is the flash department. So next to the flash is financial and accounting department. And after we will go to this desk is, in fact, they take care of the PAO and for all the website and everything. This is a bio department with some. Okay, so we changed the building, and now it's the place where we manufacture all the column. It could be ASP column, HPLC, flash, or prep column. And we have a special way to pack them. It's very important about the density. This is the step of cleaning silica or polymer. And we have 3 different grades of silica and more than 50 bonded, as told Dominic. This is a warehouse where we stock all the different kind of column. And now we are going to the other town next to Montluçon. It's Saint-Victor, where we manufacture all the instrument. We manufacture from A to Z, in fact. And at the end of the building, you have a door room. I want to speak about this place because it's a testing room where we test before to ship like that the instrument. We test all the instrument, and we are the only one to do this kind of test. It's very important. Let me show you. The test, in fact, can you give you a report? It's a compliance report with the name of the instrument that you bought and the serial number, and everything is tested. The flow rate, the gradient valve, the pressure, and everything. So you get this the result with the delivery of the system. Now, a short story of Interchim. Interchim began in 1970. Mr. Jean Bock created the society. And at the beginning, he focused on chemical and analytical science division. But step by step, we went to purification. And an important date was 2008, where we began our first instrument. And during 10 years, we managed the instrument. And the second important date, it's only 2 years ago, where we changed a lot of things about our instrument. In fact, we are the only one to focus on the both. You have flash chromatography basic with some chip techniques, no innovation, like ISCO, Biotage, and others. And you have also, at the other part, you have the high quality by pure chromatography, HPLC, or prep with water, Agilent, and others. And we focus on the both. I mean, we take care of the quality of HPLC, and we dedicated to the prep and to the flash system. So we manufacture instrument and consumable. As you saw, we do synthesis, analysis, and our main field are purification for low and high pressure. I prefer to say low and high pressure than flash and prep. So you saw this step, it was cleaning. I spoke about the importance of the density of when you pack, and we have a trading mark for that. So we do bio column, flash, prep, and HPLC column, and from the different size you see here and the length. Small words about our place in over the world. We have more than 60 countries, and we have 3 subsidiaries. We have one in USA, one in UK, and now one in China. As you know, maybe we have a new combination with Avion, and a lot of things moving at Interchim. Just an overview of our customer. You know certainly some of them, Roche and others. So our domain are academia, chemical, process, food, beverage, petrochemical, environment, and biotechnology, cosmetic, a lot of different customers, pharma, of course. So why we change our system? Because we launched more than 10 systems during 10 years, and we changed everything. Because in fact, chemists need it. We totally redesign our system to meet the demand. you must understand that we must reduce the time to develop the drug. So for that, we must increase the productivity, and we work for the colon to get a better way, and also for the instrument. And for that, in fact, it's not evolution. Since 2 years, I mean, it's not really evolution. It's more than revolution. And this revolution begins with an application on your phone. The name is Intershim. You can load it on Google Play. And this application can give you, I think it's much better to show you a movie, and you will understand quickly what this application can give to you. So use, okay, let's.
Yes, Jean-Pierre, we are not able to hear any sound.
Sorry?
Could you just explain while the video is going on? We're not able to hear any sound in the video.
Wait 10 seconds more, please. So by this way, with this short video, you saw the advantage of the TLC application on your phone and how it's easy to send to your system by Bluetooth. And then you have also a quick overview of the software Intersoft X. So you understood that Genius with artificial intelligence can bring you a lot of facility, because the system will propose the best choose of the colon, and in order to do the purification in a shorter way. I have also another video, but I will do quickly because we have not so much time, just to compare the Gen 4 to Gen 5. And just to explain, during this several last year, we think about all the needs of the customer, and we must find the solution. So here, okay. Just quickly, because it's too long, but I just want to, oh, cannot see it. Sorry. Let me try again. Okay. I know, I cannot increase it. I cannot. I don't know why. Okay, so just to explain, you saw this way, instead of to take a photo of instead of to use a calculator, ruler, and to measure the different spots, You just have to take a photo and adjust the front line and send to the system. This was with Gen 4 on the left and Gen 5 on the right. Then the system get the TLC and automatically will propose to you, wait a minute, let me find here. Yes, it will propose here the best column. In this case, it's a column 12 gram with 15 micron for the particle size. And if you see later, when we launch the run, you see the first peak arrived very, very quickly. And this is an important fact. You can see the flow rate is 85 ml per minute because the Genius is able to calculate the higher flow rate and to keep the pressure above 20 bar, because you know for every flash column, the maximum pressure is 22 bar. And in fact, with the Gen 4 here, you can see the flow rate will be only 15 ml. It's because at the end, the 5 peaks will arrive because it's a purification for 5 compounds. The 5 peaks will arrive very quickly with Gen 5. It's not easy, sorry. Let me check here. So you see the 5 peaks will arrive only in 5 minutes. And with Gen 4, before, just to take, to fill up the data, it took a lot of time. And you see you have only 1 peak here. So just to prove that with Gen 5, you win a lot of, you reduce the working time and you help the chemist. The software Intersoftics is very easy. In fact, you have 2 pages. You have a quick overview, just the video before. And you have also, so whatever is your sample, in fact, you will have the best solution because Genius, artificial intelligence, will propose the best column to do the purification on the quicker way. So flash and go, this is a technique with the photo and your system application. You have a boost and go. It's a button that you push and you will increase the flow rate. And you have also the load and go. Load and go, it's in fact a system. Let me check if I can. Here, I'm sorry for it's not easy to manage because I must do quickly for that. Load and go, in fact, it's whatever the system will manage the loading sample, the calibration, and the cleaning at the end of the system. So it's the pathway, fluidic, we change and we adapt whatever you need, if it's loading sample or cleaning or equilibration. The system will manage automatically. So another important point that the added value of Gen 5 is, of course, RFID, because you have RFID for column, for dry load, racks, and loops. You have also solvent level monitoring, waste level monitoring. You have a status light. In fact, when you know every time what is the status of your system, if you inject, the color is yellow. If it's equilibration, it's blue. And if it's running, it's green. If you have a problem, it will be flash, red flashing. You have also leak detector for valve, pump, fraction collector, and the ILSD if you have an ILSD. So the more important word for this new generation is simplicity. In fact, we want to do the purification easier, intuitive, and productive. This slide is to help you to find and to choose the adapted system. In fact, it depends of your purities that you expect. If you expect 97%, for example, the XS520 will be enough because it's low pressure and this system can accept until 20 bar. And depending of your purity that you expect, you will have each system here. It could be useful to choose your system. Here is the full range of our system. So you have here 3 flash, 3 low pressure, 20 bar for this one also, but with a lot of security. And this one is a crossover until 50 bar. You can see the flow rate is 250 ml per minute here, and for the 2 first, it was 300. You have then the prep system. Prep system is 250 ml per minute and until 125 bar for this one. You have 250, and we have also ultra prep system. We can accept until 400 bar. Then we have 3 systems that we call them process system, because you can the flow rate is much more than the other. For example, for the last one is 825 ml per minute, and it can accept 15 bar. So depending of each system, you have the flow rate and the pressure, maximum pressure. And we have also 3 systems dedicated to the protein or peptide. In fact, 2 for the peptide, this one, 125 bar with 250 ml per minute. This one can accept 250 bar, but the flow rate will decrease a little bit, and it's 125 ml per minute. And the last one, but I think we will speak about that later. It's a protein system. So don't forget about the added value. RFID, I speak about that, solvent level monitoring, foam enclosure, waste level, system status, and leak detection. The important also added value are the boost and go, load and go, and flash and go. I explained already about that. And Arjun and Mr. Mani told me that I must speak about 2 systems. The cheaper one is the PuriFlash X Access 520, 520. This one is ultra, because you have on the right side, you have the possibility to add a valve, 4 electric valve. We manage the loading sample. It's a pump dedicated to the prep or flash in this case, with a dual piston, and 2 catenary gradient valve with another weight for airway purge, but we cannot see here. We have also a high pressure mixing chamber. And in fact, we done this system at the beginning for the university, because they asked for a ship system. But now a lot of CRO like Pfizer, Bayer, Merck, or others are buying it by batch. This is a 15 inch for the touch screen. And you can use a column from 4 grams to 800 grams. It's really the perfect system for routine purification. What I can say more, it's you have here for the fraction collector, you have 2 racks, 2 long racks with 112 tube. Yes, here it's writing. You have also a drainage system for at the bottom. I spoke about the touch screen, and you have, of course, Intersoft with Genius Artificial Intelligence. This is Ultra with the 4 valve electric. And what is important also is, for example, you have UV. Normally, by standard, it's UV 200 nanometer to 400. But if you want, if you opt for the ultra system, you will have 200 until 800 nanometers. And it's very easy to change the cells. You have just a door, you open it, and with your hand, you can change or clean the cell very easily. I told about the real quaternary gradient pump. You have, so I think, yes, flash and go. So you can send the TLC by Bluetooth directly to the software, and the software will propose and manage the best purification on a shorter time. So for this one, I will also let Arjun explain if he need more. But let me, so of course, 300 ml and 20 bar, and accuracy and repeatability. It's very the best system for the routine purification. And then at the opposite, we have the prep system. So the other systems that Arjun want to speak about, it's prep system. So versatility for this system. Of course, it can accept 250 bars. So if you have complicated separation, it's the system, the best system for that. You have also the screen 15 inch. You have, of course, Genos with the Intersoft X for the software. We have a fraction collector with 3 racks and 132 tubes. This system can accept a column until 80 millimeters for ID. And the flow rate that they can accept is 250 ml per minute. Very small, but hyper powerful. The pump, I spoke about everything. You have also washing disk. Yes. So in fact, you can have an option with the pack multi, and by this way, you can add a third column. So you can have, for example, 2 preps column and 1 flash column, or 2 flash and 1 prep, or 3 prep, up to you. And the system will be managed automatically what you will program. You have option for, of course, UV extended for ILSD. The ILSD detector is on the other side. It's very easy also to take care of it if you need. Pump washing disk, I explained already, and the pack multi, I explained that it's the third for the third column. You have also peripherals that you can add, Purivap 6 or mass system for the third detector. And you have different mass, 1,200 or 2,000 mZ. Auto sampler, second collector, carousel, and multi-waste. Okay, for this system, a few words about the software and SoftX, because we took a long time to find the better way to have a perfect software. Now it's very user friendly. You have on the left the status bar, and on the right status of the system. It's never changed. You can follow the pressure, you can follow the flow rate, you can follow also where the fraction collector, where the peak is. And you have a solution table on the middle here and the method. So you can do it automatically by with Genius by sending the TLC. You have here 2 buttons. And you can also do as you want by hand if you want to fill up as a normal system. And you have also the second page is in fact the living run. So you can follow and adapt also. You have UV spectrum here, and you see exactly where are all the racks and the tube is filling during the run. I don't know if I have enough time now to speak about SPE. First, before to speak of SPE, let me repeat about the pack. So you have UVA extended, the possibility to extend to 800 nanometer. You have ultra, it was for the 520. ILSD, it's an option. If you want integrated ILSD, you can ask for that. And which is very important, it's Saga. I must speak about Saga also. Watching pump disk and the pack multi. Peripheral, I explained already, mass, auto sampler, carousel, multi-waste. You can ask for that, of course. And a few words, a few numbers. So we have the flow rate range from 125 to 825 ml per minute for the process system. We have 15 bar up to 400 bar for the prep, ultra prep system. Got to make step 0.1%. It's very important. And I explain everything what we write on the paper. As you will have the compliance report at the end, we prove that it's true. So I explained about the dual piston for the pump. I explained already the constant flow rate, whatever the pressure is in system. Yes, an advantage compared to the competitor. When you say, for example, for the XS 520 300 ml at 20 bar, that means the both together. Most of competitor write 300 ml, and in fact, it will be not 20 bar, it will be the pressure will reduce depending on the flow rate. So please note, it's advanced pump technology, SPL quality, and built to last. And another few numbers, the accuracy is very important, and the linearity and the gradient step tolerance. This is we write and we prove that it's the best quality of pump and gradient. The three different detectors, UV extended, of course, IBSD integrated, we can see here. It's with Saga technology. We can we speak next slide about Saga technology and mass. In fact, if you use mass, you must use interface, because our intership interface is important, that I speak about that. We have dynamic split, automatic dynamic split. It's not MRA pump valve as the other. And we have also a dilution pump. So it's prevent to, the dilution pump prevents the clogging, and the automatic split can accept, we have no problem with the column, because we have no problem with the flow rate, so no problem with the back pressure. So we can accept whatever is the column. A few words about ILSD and about the Saga. In fact, you see the nebulizer. In fact, Saga, ILSD becomes unsaturable. It's an algorithm. We manage in real time the gain and reconstruct the chromatogram. So you will have never a problem of saturation. If you see here, no, sorry, I canceled the slide. Okay. Last word about the knowledge. We share all the knowledge. You understood that inside the system you have genius and software. In fact, inside we have all our knowledge, and we share all the knowledge. And for example, we have a blog, and we have also a website. The name is flashchromatography.com, if you can note it. And this website, try to open it. By this way, you can try to configure your system. For example, if you want to choose a flash system, you just have to click on it. And at the bottom of the page, you will have all the explanation, of course. You can choose your option, what you want. And if you need a demo, of course, Mr. Mani and Spico or Aragon will get your request and will be able to do a demo system with the system, or explain more about the system that you will choose. You have a lot of different systems, prep or flash. And oh, sorry.
Yeah, thank you very much, Jean.
Yeah. Okay.
Now I would request Arjun to give a glimpse of our solutions and support from Spinco.
Yeah, just about, I forget to speak about the blog. Blog is also an important website, if you can note it, because you will find a lot of information about purification, about analysis and everything. So don't forget to click. And also, sorry. Okay. And the last one is the TLC application. I told you that you can download on Google Play. Don't forget to download it. It's for free for everybody. Okay,
Right,
so I finished.
Thank you very much, Jean-Pierre.
Thank you,
I now
Arjun.
request Arjun G. Raj from Spinco Biotech to begin the next talk about internship support in India. Yes, Arjun. Yes, Arjun, you are muted.
Yeah, Arjun, put it in a slideshow mode.
Just a minute, sir. Thank you, Jill. Thank you, Devansh. So good afternoon, everyone. Thanks, Jin. You have completely covered all the portfolio, everything. So what was there, my role, you have completed it. So briefly now, I will speak about the support from the Spincotech. So as we are a channelized partners for the Interchain Complete Pan India, we have a dedicated team to support before sales, after sales as well. Because once the system is sold, there will be a dedicated application team from the Spinco. There will be a dedicated service team from the Spinco where they will come into your place. We will install complete system, and then once the installation is done, our application team will be there to help you or guide you in the development of the method or to learn about the software. Each and everything will be taken care by the Spinco. Because if you take complete pan India, across pan India, we have more than 650 people who are helping in and out, like pharma, non-pharma, CROs, everywhere we are present. And we have a dedicated team to focus on a flash, and we have a dedicated service team for flash chromatography, and we have a dedicated application team also for the flash support. So this is the one of the biggest advantage what you have from the Spinco, so that if you have any interchim system, flash chromatography system, you have a dedicated team who will come to your place and we will help you out each and everything from the beginning till the end of your sample analysis. So this is the major advantage what you have from the Spinco if you have buy any interchim system or if you're planning to buy the interchim system in the future. This is just a quick view of our corporate offices. So we have a Spinco Towers Chennai. We have a head office in Chennai where it is more than 50,000 square feet. So that is our head office. And we have a regional office spread across pan India. So if you take, we have offices in Hyderabad, Bangalore, Mumbai, Pune, Vizag, Ahmedabad, where we have a dedicated labs to support the customers. And we have a demo systems as well, where we take some samples, do the analysis, give them the results, and then we'll go ahead with the further processing of the buying of the instruments or any other support required from the customers. So this is a quick view about our corporate, like how we have spread across pan India to support completely, starting from the sales till to the end of your purification from the Spinco Biotech. So as we have authorized channel distributors, completely starting from the instrument buying till you buy the flash columns or the training, everything will be taken over by the Spinco. As Gene has explained before in his slides, I will just have a quick summary just for 5 minutes. I will run the show and I will just go through the summary what Gene and Domain has explained. Now Interchim has launched the 5th generation software where no one is having, if you take any other competitors, only Interchim is running with the generation 5 advanced software. So what is generation 5 advanced software is, as Gene shown you in the video. So you have a very quick access or you have a very easy methods to do your purification. One, we call it as a flash and go. That is, you can just take the picture from the TLC, send it to the instrument through your mobile from the Bluetooth. Then automatically method will be set and it will tell you which column has to be taken. And according to that method and the gradient will be set. And once the gradient is set, if you want to change it or manipulate, that also can be done. And you can do your methods along with your type or if you have any existing method. So this flash and go, what it will give you an idea is, for the any new beginner or the learner, it will just give you an idea to set how to set the gradient and how to choose the column. So this will be the good advantage if you are going with the Interchim 5th generation advanced software, where we call it as a flash and go. And one more advantage is any users can download this app in their mobile and they can take a photo and through Bluetooth, they can share it to the instrument. This is the first advantage. And the next is boost and go, as Gene shown in the video. If you're running the sample in 10 ml or 20 ml for an example, if you want to increase the speed when the system sample is running, you can increase into 2 speed or into a 4 speed, where your analysis, if it is taking 45 minutes of time, can be done within 5 or 10 minutes. Then load and go, we have a multiple systems as Gene explained. So these are the flash system. And here the unique advantage of this system is you can connect multiple columns in a row and you can set a sequence. For example, you can connect 2 flash columns or 2 prep columns where you can put up the sequence, the starting analysis or the starting sample will go to the flash, then it will pass to the prep, and then you will be having different results of the chromatogram. Depending upon the separation pattern, you can choose your chromatograms and the columns. So these are the basic models and the flash systems what we have, depending upon your requirement, whether you need a UV or ELST, based on that it will come. These are the flash cum prep system, where these systems are able to withstand 5 micron prep columns where you can use your 5 micron preparative columns up to 30 mm or 40 mm outer dia. So it will be a very good system where you can use both flash columns as well as a prep columns in a single system. So majorly these are the five different preparative flash systems we have in this. Depending upon the requirement or the requirement of the users, we can give either 125, 250. The 5 stands for 5th generation, and the next after 5, 125 stands for 125 bar. The system can withstand up to 125 bar. Same like that, 250 means 5 stands for the 5th generation software or the advanced system. 250 stands for the bar that system can withstand. This is the basic system what we have from the Interchim. So for research academics and all, this will be a very good system where this system comes with a flow rate starting from 1 to 300 ml per minute, and it will withstand up to 20 bars. So you can use flash columns starting from 4 grams up to 800 grams as a inbuilt. There will be a column holder where you can fix the columns. If you want to use bigger than 800 grams of columns, then you can go ahead with the clamps, external clamps, where you can use the 1.5 kg columns as well. So this is the one of the most advantage what to have it in our basic system. And this system comes inbuilt UV 200 to 400. If you want to change it to 200 to 800, that option is also there. This is the flash cum preparative system, which works for the both flash as well as your preparative analysis. This system can withstand up to 250 bar, whereas the basic system can withstand up to 20 bar. So depending upon your requirement, you need to choose which system has to be selected. So in this also, you can collect multiple columns. Like if you want to connect more than 3 or 4 prep columns can be connected. You can put up a sequence one by one, the method will done. And depending upon the loading sample, the sample will be passed into the different columns. This is the advantage what Gene was explaining. One of the advantage what only Interchim is having is a fume enclosure. I think you have noticed in the previous slide here. So the whatever fraction collection rack is there, it is completely closed. So this is an extra additional what we have it in Interchim system. We call it as a fume enclosure. Whatever fumes are there, if you take other systems, all the fumes will be coming out when the fraction collection is collected. But here what happens in our system is completely it is closed, and if you keep it near the back end of the window of your lab, due to the exhaust fan, all the vapors will be sent out of your lab. So this is the advantage. If you don't have a fume hood also, you can use this system without any problem which causes fume or any other such bigger problems which happens due to the fume. So this is the additional advantage what to have it in the Interchim flash chromatography system, that is a fume enclosure. And we have a solvent leak monitoring all the ways, like starting from the solvents, whether it is a waste or it is a solvents line, we have a solvent level monitoring system. If you are taken and if you have filled 5 liters, once it is 4.8 liters, then automatically there will be a pause and it will be giving a caution you that the solvent level is less and you need to refill it again. So system light status, this is nothing but if system is completely good and if it is in running mode, it will be showing you green color. If there is any issue with the pump or with the washing, or if there is any blockage in the system, automatically it will be showing you red color, where you need to call your engineer or you need to rectify what is the thing, and immediately you can just start. This is just an advance of the software where all the indication will be given you by the software. Within a 5 or 10 minutes, you can cross-check each and everything and you can start your analysis. So next, this is about the different detectors what we have. Standard system will come with UV 200 to 400. If you want to complete range, you can upgrade it to 200 to 800. We have an option like integrated ELST, depending upon your needs. Suppose if you want to analyze non-chromophoric compounds, non-UV active compounds, then you can go for integrated ELST system. That also we have, which comes the system along with the integrated ELST. And future, if you want to upgrade our flash chromatography system to mass, yes, we have a dedicated mass detectors also, where it can be embedded into the running system or it can be upgraded anytime. So this is the, again one more advantage what to have with the Interchim. Next comes about the method transfer, where it is very easy. As Gene has explained, you can just take the photo and send it to the instrument. Automatically the gradient will be set. Once everything is done, next comes to the picture is the software. How easy the software for the user. We have very few inputs to just to start your method. In this, what happens? Only the solvent you need to select first, which are all the solvents, and what is the column size you want to run it, and what is the injection mode, whether it is a liquid or a solid, and then what are all the gradients you want to set, and what are all the parameters, whether if you want UV 6 lines or if you want to have UV 2 lines or 3 lines, this you want to just set it, and you need to set a gradient. Just if you set a 5 parameters, not more than that, and you can start your method. So this is what we call it as the 5th generation advanced software, which is very user friendly. So as if now, if you take a Spinco, we are marching towards 50 interchange systems in India, where we have a big partners like Syngene, Biocon, and if we take a research academia, where we have given the systems in LM College of Academy, we are given in KIT, we have given in Satyabama University, we are given in TNAU, and we are spread across India. Now recently we have given in Pune also, Pune University and DML Patil University, where Flashcom proprietary system. Complete pharma and non-pharma, we have a footprints and we have a dedicated system to support. And now, as this support from the Spinco, we are marching towards 50 systems interchange across pan-India. And thank you.
Yes, sir. Thank you very much, Arjun. Yes, so now we would proceed to the final panel discussion. I request the panelists to please turn on their cameras. Yes, sir. Dr. Yadav, is your audio working now? Is it fine now?
Yeah, it's fine now, sir.
Yes, sir. Professor Mishra? Yes, sir. Professor Mishra, can you hear? Can you hear us?
So maybe you can call Professor Mishra.
Yeah, just calling.
Okay, so now we'll quickly take up the Q&A sessions. So the first question is a general question for our expert panelists, Dr. Yadav and Professor Mishra. So, sir, could you just give us a brief insight about the kind of research that you're currently doing and how you're using purification in that? So,
Yeah.
Dr. Yadav?
Yeah, thanks. Yeah, actually that time audio and video both were not good. Now audio is connected. Okay, please
Yep,
pardon me.
Professor
Thank you.
Misra is also there. His audio was mute.
Yeah.
All right, all right. Yes, Dr. Yadav, Professor
Yeah,
Mishra.
first of all, I would like to congratulate you all for conducting this nice webinar, very informative actually. And as far as in our laboratory, we are doing both, we have the interchange system 5250. We are doing both flash chromatography and both applications we are doing. So from simple compounds like different, we are dealing with plants. So simple compounds like leaf extract, so carotenoids, chlorophylls, and these things to complex like wax, different types of wax and different separations in the oils we are doing, phenolic compounds we are doing. And for the antioxidants also we are trying to standardize. And one most important thing is that the service application support, what we are receiving from Spinco, that is fabulous actually, marvelous. Whenever I will have some problem or something, immediately the person will come or by their phone or by this webinar, this video conferencing, they will solve everything. So till now I am happy, and if anyone have doubt in this oils or wax and these purifications, they can contact me or they can ask any questions if they are having. Thank you.
Thank you very much, Dr. Yadav. Now, Professor Mishra, so what kind of research and work are you currently doing at Prante? So I went through your website and it seems really amazing, sir. So if you just give us some insight on how you're using purification.
So we work mostly on making nanosensors, and gold nanoparticles, magnetic nanoparticles, quantum dots, and then bioconjugation of those nanoparticles so that can be used for research as well as diagnostic applications. So apart from Prante, I also have a small academic stint where I do basic research in the area of photonics mostly, and my specialization. So I've used purification technologies mostly to work with peptide chemistry. So we make synthetic designed peptides, and therefore you purify them. HPLC is fine as far as it's small quantities, but when you want to work with bulk quantities, then HPLC loses its capability, and that's where flash comes into picture, because synthetic peptides are usually pure by themselves. You at least get synthetically, you are 90-95% pure there. What you need to do is maybe just a cleanup round, for which we use flash chromatography. We are trying to develop some methods to purify nanoparticles, but that's a challenge in itself. It's not so easy to use existing purification technologies to work with nanoparticles.
All right, all right. Since you mentioned peptides, sir, so we have one question in the Q&A box. So what precautions should we take for purification of nucleobases, sugar molecules, and peptides on flash chromatography?
I think as far as the peptides integrity is maintained in the solvent system that you are working with, that's good enough. But you also have to remember, when you are working with biological material, most often aggregation is a problem, which is not evident to the human eye. So what you may presume to be a soluble molecule may not actually be a soluble molecule. And that's where there are huge issues in binding to the column. So your molecules will usually elute out much faster than they should. And that's where you need to tweak around with the solvents. So essentially, you need to ensure that your molecule is as a molecule and not as an aggregate.
All right, all right. Thank you, sir. So, Dr. Yadav, we have one question related to plant and phytochemicals. So, can we identify vegetable chemical compounds and nutritional compounds by flash chromatography?
Which type of compounds?
Sir,
Nutritional
vegetable chemical, yeah.
yeah, this different colored compounds easily we can do, like chlorophyll, xanthophyll, carotenoids. These we can separate very easily from this. And nutritional compounds means which type of compounds, like sugars or proteins or any antioxidants? What type of nutritional compounds? If
Sir, all of them.
yeah, we can do. Most of them we can do. Yeah. If we
All
have
right,
any HPLC or UPLC method, we can do these things also. Because we
all
have to,
right.
after this purification, we have to identify from there our compound. We have to cross check.
Okay, so the question was regarding antioxidants, but yes, according to sir, it's possible. So the next question is, sir, how can we separate phytochemicals extracted from plants which are very close to each other in terms of polarity?
Then we have to change the ratios of solvents, sir, and heat and trial. Because sometimes I also face that peak on peak, merging peaks on HPLC. Those compounds we very hard to separate from this HPLC. So in that preparatory we can do, but in flash very sometimes we are facing difficulty in flash. Yeah, preparatory we can identify.
All right.
So
So,
I can add a little bit there. So what you can do is try a two-dimensional separation. For example, use one solvent system to do your first round of separation. And now each of the fractions that you get, now use each of these fractions using a separate solvent system. So in this way, you will be able to most of the times separate out otherwise unresolvable compounds.
all right, all right. Thank you for your input, sir. So now I would like this to be an open question for all the panelists. So one of the most common questions that we generally face is how to choose between a flash system and a prep system. So what are the parameters do we need to keep in mind? And is there any intermediate arrangement available? This is an open question to all.
I have already written something approaching this question on the Q&A question, explaining that the flash chromatography is made for generally raw material, having difficult separation, and we keep the product of interest and go up to a preparative one. But it's possible to do the same thing immediately with the flash chromatography. It depends completely about the selectivity of the flash chromatography we have chosen, on also all the parameters about the selectivity, and it's sometimes linked to the efficiency parameter, and efficiency immediately induce preparative because we can pack some flash column with small particle size like 5 micron or 10 micron, because the plastic column is not made for that. And we have to choose a preparative one, allowing a big efficiency with 5 and 10 micron particle size, leading to a good separation. So it's difficult to put a boundary between the both. More and more, we have some overlapping on the prep and flash chromatography, depending about the goal we are looking for.
I would like to add here.
Yes, sir.
To address this particular problem only, Interchim has a solution of flash cum preparative chromatography system. That is 5250 system, what Dr. Padman Yadav is using. See, basically here, the first stage of purification is done by flash. And the second stage of purification is done by preparative. As explained by Professor Rashim Mishra, you can really play around on the expected, the selectivity and the efficiency of the analysis by using either a flash and prep, or both flash or only the stainless steel columns. The combination of anything can help if you are going for a flash come preparative system. Whether if your laboratory is already using a preparative system of other dedicated preparative system, then probably as a complementary tool, you can add a flash system. Try for the first purification using cartridges, then take those fractions and do it in further in the preparative system.
All right. Thank you. So, what are your inputs, Dr. Yadav, Professor Mishra?
Yeah, so I would say loosely, if you classify them, you call it a preparative column, or you use a preparative column when you are really looking at high amounts of resolution. So you have, say, maybe large quantities of two molecules which are very close to each other, and you need that amount of selectivity. That's where you use a prep column. But in the real world, there are very selective cases where you need that kind of a scenario. Most often your compounds are very easily resolvable in standard flash chromatography. The difference between flash and preparative column, as we say very loosely, is the limit of resolution that you can achieve between two different molecules. So if your molecule is pure enough, 80% pure by default, then flash serves as a very good way of cleaning it up. Whereas if you are making, sometimes you end up having enantiomers, or you end up having a D and a L form, or some slight mismatch while making a peptide. Say one fraction has missed one amino acid during the synthesis. These are situations where you badly need a prep column to be able to separate between these two molecular entities. But again, running a flash cycle before you go to a prep cycle is always a good idea.
All right. Thank you for your input, sir.
Yeah, excuse me. Yes, sir.
Yes, sir.
Yeah, I do agree with Professor Mishra, but in case of some biological compounds and the crude or complex compounds, we do need a prep also. For the simple synthetic compounds and in pharma, that what we call flash is sufficient, but for this biological research, prep is also required. So before going for prep, we need flash chromatography also. So people can choose based upon their application actually. This is case to case. We cannot suggest you purchase flash or prep or what. Okay, sir.
All right. Thank you, sir. The next question is flash chromatography useful for separation of lipids, purification of lipids from biomembranes?
Actually, we have not done this, but theoretically
Yes.
it's possible.
All right. Sir,
Yeah.
one more question for Professor Mishra and Dr. Yadav is, what is the accuracy of enzyme purification in flash chromatography over other conventional techniques?
Yes. Actually, we are doing some enzymes also, but enzymes should be robust, because we don't have any things to control the temperature. Actually, some enzymes they are heat labile, we are facing problem. Some robust enzymes like peroxidases, and these we could identify, and we could do extractions also, and it is much better than our traditional column chromatography, like what we are doing in the Safedex and DAE cellulose columns. But enzymes should be robust in terms of temperature sensitivity. Some enzymes we are not able to purify.
All right. Yes, Professor
Yeah,
Mishra, your views?
again, yeah, same. So I would go more by the purity. If again, conventional pharmaceutical companies, or those kinds of setups, if you are making a enzyme 2% or 1% contamination by other cellular entities don't really matter if you are getting 98-99% pure yield of the enzyme. So flash is pretty good enough. Again, so at every point, chromatography by definition is art and magic. You know, it's art and science together, which makes magic. So there is no recipe. It depends upon what is your matrix, what is the nature of your matrix, what is the nature of your molecules interaction with your matrix. And that is very often predictable, but there are times when they don't behave in a predictable fashion. And that's where experience matters. You know, I typically take at least 20 to 30 runs to optimize a particular gradient path or a process. And I think that's very usual. Sometimes you're lucky, you just get it done in 2 times. It all depends upon how your molecule behaves with your matrix.
All right. Thank you for the excellent insight, sir. The next question is for Mr. Dominique Daquer. Sir, what grade of solvents can be used in flash chromatography?
What I don't understand
Yeah,
the
what
question.
grade of solvents do we need to use for flash? Is there a particular grade of solvents?
No, you can use every kind of solvent you want because it depends about the solubility of the solvent each other in the flash chromatography as in analysis or prep way. There is no real rules. I remember I saw a question about some additional compound in the solvent like acetic acid or triethylamine. So it's still possible just to cancel the tailing of the peak, but the problem finally for a purification is to obtain also the triethylamine in the final sample purification. How to manage to retire this compound in the final pure product we have is more difficult. That's why in flash or prep we try to avoid some adjuvant inside the solvent just to be able to have the pure compound after evaporation at the end, if possible also.
All right, thank you. And another question is, can we use flash columns multiple times?
Of course.
Yeah, it's possible sometimes. Sorry, Professor Rashim. It's possible sometimes. I know some customer doing that, especially with the reverse fuzz, because the reverse fuzz column are more expensive than the virgin silica gel ones. And the rule is just to be sure that the bed of the silica gel has not moved inside the column, just to be able to reproduce the same separation after that. Because if you have a small void volume at the top of the column, the separation will be completely destroyed.
All right, thank you. So it will have another open question for all the panelists. So now India is becoming one of the leaders for natural medicines, for APIs, and lots of other pharmaceuticals. So how do you see purification playing an important role? The role of purification technologies in these different domains.
You know, there's no chemistry without purification.
Yes, sir.
There's no industrial biology without purification. So if you are doing it, then purification is so intuitive that you don't even consider it as a step these days. It's a part of the synthetic procedure.
Yes, sir.
Okay, so there's no way you can say it will be important. It has always remained important. It will always remain important. No questions about that.
All right, all right. Thank you, sir. Yes, Dr. Yadav.
Dr. Professor Misra already he explained. We can, this is actually very essential. We cannot say it is important. It is essential only.
Right.
Yeah.
So the Dominique Dequer and Jean-Pierre. So what all application areas do you see for flash where flash chromatography can be utilized?
It's a huge question, in fact. I'm not sure we can explain in a few minutes so many things. I saw a lot of very interesting questions, but there are just approaching very huge explanation. That's why I have already written some explanation of certain question. I hope to be able to keep all the question and be able to forward to you some explanation about that. And I hope you will be able also to forward to the end user after that. I think it's very difficult to answer to
Sure,
everything,
sure.
to every rules of chromatography in a few minutes.
Sure.
What,
Okay.
What's your point of view, Jean-Pierre?
Yeah, if Dominic can get back all the question, and it will take time to answer, because
and we have to cooperate with a lot of person in internship also, because the subject
different department. Yeah.
Yeah.
Sure. So yes, we are almost overdue by 15 minutes. So just one last question for the expert panelists. So, sir, Professor Mishra and Dr. Yadav, so how do you see the future of flash and purification technologies? Any inputs you have in mind, sir? Because we have Intershim with us here today. So how do you see the future of purification technologies?
So, if you look historically, flash was the first kind of purification. Your preparative HPLC came in much later. Okay. Now, when HPLC came in, it was so convenient and it gave so good results that people kind of, took flash chromatography to the side and tried to move on completely to HPLC. But now we see an era when industrial chemistry and industrial biology is, going in a very big way. So volumes are going up. And when volumes go up, flash often solves 60%, 70% of the problems. It is cheaper to do. It's much easier to optimize. So I really don't see a reason of thinking that whether flash has a future or not. I think it will be one of the frontier techniques that will go parallel to standard, reverse phase, HPLC kind of techniques.
All right.
Yes, sir.
Thanks, sir.
Actually, before answering this question, in the chat box, I'm seeing that people are asking that can we purify antioxidants? And Mr. Nikhil Tribhuvan, he is asking
Yes,
antioxidants.
yes, sir.
Yeah. And so many questions are there. First of all, I want to clear that different compounds like primary or secondary metabolites, they are having different antioxidant capacity. So if he is clear which type of compounds he want to purify, then specific compounds, then I can answer. Because proteins nowadays, we are seeing that proteins also have some antioxidant capacity, carbohydrate also, some phenolics also, vitamins, they are having antioxidant capacity. So if he can tell his matrix or his compound or specific thing, then I can answer. Regarding the future of this flash and prep, actually we have evolved from manual to this. Now we are software driven. Now we are doing in our mobile phones, apps, and these things. So principle is same. Just we are in changing our applications. Principle is same only. So this is, we cannot predict the future, but this is a prerequisite and essential things. So in future it will go like anything. Yeah.
Yes, sir. So we believe future will be more towards a more user-friendly interface.
Yeah.
So AI will probably play a bigger role.
Yes. The same thing I want to convey, that initially when we were doing our MSc PhD, then we were using simple that glass columns and these things. Slowly this prep and flash has come as an along with softwares and these things. Now it is user friendly and helpful for us. Yeah.
All right. Thank you. Thank you very much. The key takeaway message is we need the correct balance between preparative and flash chromatography as per our application. Thank you very much, all the panelists. I would now like to request Mr. Basant Kumar Padi to deliver the vote of thanks.
Vanch, may I add something,
Yes,
please?
yes, sir.
Yeah, just for Professor Ashin, as you work in peptide field, I just want to know if you know or two system dedicated to the peptide.
I couldn't hear you.
I just want to know if you check the features of our two systems dedicated to the peptide.
We haven't done that so far.
Okay. So
we
Arjun can
yes,
share
we'll discuss that offline. Yes.
Okay. And also, I'm wondering if a customer of Spinco knows that Interchim can help about the transposition from HPLC to flash or prep method. So we can offer services when, of
Yeah.
course, you have a contact with us. Okay, great.
Right. Thank you. So yes, Basant sir.
First of all, I would like to thank you to all our honored customers and the participants. And I would like to thank you to Dr. Pradyuman and Professor Asim for joining us as a panelist. And hope the interaction is quite useful to our all customers. It's a wonderful interaction, question and answer session. And I thank to Dominic as well as Jean Pere for your wonderful presentation and technical session given to our users. And I thank my team, my Spincoids, SR Manivannan, Arjun, and Devans. Thank you. Thank you for joining us for this wonderful session.
Thank you very much,
Thank
dear
you very
panelists.
much.
Thank you very much. If you have any questions, please write to us. Follow us on LinkedIn to stay updated to the latest events. Thank you very much. We'll be
So
signing
Thanks,
off.
thanks, Team Spinko. It was a pleasure joining you. Take care. Have a good day.
Thank you
sir.
very much.
Thanks a
Thank you
lot.
very much, sir.
Bye, Professor Mishram.
take
Thank
care
you,
of you.
Professor
Thank you
Azim.
very
Thank you,
much.
Thank you,
Dr.
Devans.
Pradyuman.
Thank you, Basanji.
Thank you, sir.
Thank you very much,
Thanks
sir.
a lot.
Yeah. Okay.
Yes,
Bye.
sir. Yes, signing
Thank
off.
you.
Thank you.
Goodbye,
Signing off.
everybody.
Thank you.